Hello everyone! Welcome back to my YouTube channel. And again, I am Tiffany K. Hatton, a first-year student and Bachelor of Secondary Education major in Mathematics, who loves to explore the beauty of numbers and equation. So, through this channel, I aim to share my knowledge and love for mathematics with all of you. So, for today's video, I am excited to share with you a tutorial on trigonometric formulas, which is the double angle. So we will be exploring the derivation of the double angle formula and its real-world application. So whether you are a student struggling with mathematics or just someone who wants to learn more about the fascinating subject, this tutorial is for you. So, let's get started!
So let's start by deriving the double angle formula of sine, cosine, and tangent. So the double angle formula is used to find the value of sine 2 alpha or cosine 2 alpha or tangent 2 alpha in terms of sine alpha or cosine alpha or tangent alpha respectively. So to prove this formula, we need to use the addition formula of two angles, which is for sine is sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So let beta is equal to alpha. So it will be sine alpha plus alpha is equal to sine alpha cosine alpha plus cosine alpha sine alpha. So sine alpha plus alpha is equal to sine 2 alpha is equal to sine alpha cosine alpha plus cosine alpha sine alpha is equal to 2 sine alpha cosine alpha. So this is the derivation of double angle formula of sine. So for the cosine, so cosine alpha plus beta is equal to, so again, we need to use the addition formula of the two angles. So cosine alpha, cosine beta minus sine alpha, sine beta. So again, let beta is equal to alpha. So it will be cosine alpha plus alpha is equal to cosine alpha minus sine alpha, sine alpha. So cosine alpha plus alpha, so it will be cosine 2 alpha is equal to cosine alpha times cosine alpha is equal to cosine squared alpha minus sine alpha times sine alpha equals to sine squared alpha. So this is the derivation of the double angle formula of cosine. And for the tangent, again, we need to use the addition formula of two angles, which is tangent alpha plus beta is equal to tangent alpha plus tangent beta over 1 minus tangent alpha and tangent beta. Again, let beta is equal to alpha. So it will be tangent alpha plus alpha is equal to tangent alpha plus tangent alpha all over 1 minus tangent alpha tangent alpha. So tangent alpha plus alpha is equal to tangent 2 alpha is equal to tangent alpha plus tangent alpha is equal to 2 tangent alpha over, so tangent alpha times tangent alpha, so it will be 1 minus tangent squared alpha. So this is the derivation of the um, double angle formula of the tangent.
Since we all know how to derive the double angle formula of sine, cosine, and tangent, so let's have an example. So my example here is to find the value of sine 2 alpha, cosine 2 alpha, and tangent 2 alpha, or the double angle of sine, cosine, and tangent, given that the cosine alpha is negative 5 over 13 and the alpha is in the quadrant 2. Since we all know that in this figure, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So let's put the triangle in quadrant 2. So here, in here. So the given here is cosine. So since we all know that the SOHCAHTOA, which means sine, is equal to opposite over hypotenuse, and the cosine is equal to adjacent over hypotenuse, and the tangent is equal to opposite over adjacent. So the given here is cosine, so we need to use the cosine. So the adjacent here is negative 5, and the hypotenuse is 13. So we need to put here the adjacent, which is a negative 5, and the hypotenuse of this triangle is 13. So the missing here is the opposite. So to get that, we need to use the Pythagorean theorem, which is the a squared plus b squared equals c squared. So to make it easy, we need to use the adjacent squared plus opposite squared is equal to hypotenuse squared. So the missing here is opposite, so we need to use the opposite squared is equal to, so the hypotenuse here is the 13, so 13 squared minus the adjacent, which is the negative 5, so negative 5 squared. So it will be 13 times 13 is equal to 169 minus negative 5 times negative 5 equals positive 25 rather. So it will be 169 minus 25 is equal to 144. So to cancel that, we need to square root. So square root of 144 is equal to 12. So our opposite here is 12. 12. So since we have the opposite, so we can determine the sine alpha and the tangent alpha. So the sine alpha is, since we use the opposite over hypotenuse, so the opposite here is 12. So the opposite is 12 and the hypotenuse is 13. And the cosine alpha, which is the, what we call this, the given earlier was negative 5 over 13, and the tangent alpha is the opposite, which is 12, and the adjacent is negative 5.
Since we get the value of sine alpha, cosine alpha, and tangent alpha, so we can solve the double angle formula of sine, cosine, and tangent. So to solve the sine 2 alpha, we need to substitute the given value that we get earlier, the sine alpha, cosine alpha, and the tangent alpha. So it will be, so 2, which is the sine alpha, the value of that is 12 over 13, and the cosine alpha, which is the negative 5 over 13. So we need to multiply the 12 and negative 5. So copy the 2, and 12 times negative 5 is equal to negative 60 over 13 times 13 is equal to 169. So sine 2 alpha is equal to 2 times negative 60 over 169 is equal to negative 120 over 160. So this is the sine 2 alpha of the double angle. So for the cosine, so the cosine alpha here is negative 5 over 13. So we need to negative 5 over 13 squared. So squared, and this is the squared in out. So minus sine squared alpha. So the sine alpha here is 12 over 13 over squared. So it will be, so negative 5 times negative 5 equals 25 over 13 times 13 is equal to 169 minus, so 12 times 12 is equal to 144 over 169. So you will be subtract it. So it will be cosine 2 alpha is equal to 25 minus 144. So it will be negative 199 over 169. So for the tangent, so you need to copy the 2, and the tangent alpha here is 12 over negative 5. So copy, substitute. So 12 over negative 5, then over 1 minus the tangent alpha, which is which is 12 over negative 5 squared. So it will be, so 2 times 12 is equal to negative 24 all over copy the 5, so it will be negative 24 over 5. Sorry, I put that in the top. So the second one is 12 times 12 equals 199 times 1 equals negative 129. Then negative 5 times negative 5 is 25. So we need to reciprocal the 25 over 109. So it will be negative 24 times negative 25 is equal to 600, and 5 times negative 5 times negative 119 is equal to 595. So it is divisible by 5, so it will divide by 5. So it will be tangent to alpha is equal to, so 600 minus 5 divided by 5 brother is equal to 120. Then 595 divided by 5 is equal to 119.
Real-world connection of trigonometric concepts. So trigonometry has a numerous real-world applications such as engineering, architecture, and physics. For example, in architecture, trigonometric is used to calculate the angle of dimension of buildings. In engineering, it is used to design structures such as bridges and towers. In physics, it is used to calculate the motion of objects and waves. So, in conclusion, we have learned how to derive the double angle formula for sine, cosine, and tangent, and how to apply it in the real-world problems. So trigonometry plays a crucial role in solving real-world problems, and understanding its concept can help us in various fields. So I encourage you to explore further application and trigonometry and apply this concept in your own problem-solving endeavors. So I hope you learned something about my tutorial video, and thank you for watching.